Pretty quickly after you have a grasp on multi-element data structures like atomic vectors and lists, you're going to want to be able to write code that processes each element of those data structures. That gets us onto the topic of things called loops and iterative algorithms in programming. So let's take a look at how we might do that in R. I'm going to go to our sensitivity analysis example, and I'm going to open up RStudio with my project file. And I'm going to go back to this analysis script that is doing a sensitivity analysis, or in this case, it's taking a given rate coefficient and a given initial concentration and calculating what the concentration of a reactant should look like over time based on first order kinetics. So let's say, well, we're doing this once with one combination of a rate coefficient and one initial concentration. What if we want to do it several times with different initial concentrations, for example? So maybe we could define a vector of values for initial concentration and have one value maybe that's a little lower than 50 and another value that's a little higher than 50. So we can see what happens with our model. And this is kind of what I mean by a sensitivity analysis. We're looking at how this changes the model's predictions. Ultimately, we can make a graph of these three different predictions with the model, but first we need to have our analysis script generate the results of the model with these three different initial concentrations. So ultimately, when you're writing loops, it's good to have code that you know works that goes through your loop once. And in this case, that code is going to be everything that is going from calculating the predicted concentrations, filtering those, and ultimately putting those in some sort of data structure to save for later analysis, or later graphing in this case. So these are the lines of code that ultimately we want to repeat in a loop. In R, the kind of loop we're going to use here is called a for loop. And you specify a for loop with the keyword for. And then you need parentheses after the for. And in those parentheses, you are going to tell it something about the variable that is going to change each time through the loop. So in this case, I'm going to call this variable const_index. And why I'm calling it index is going to make a lot more sense a little bit later on. And I want this const index variable to change each time it goes through the loop. So in R, the way I tell it which value to take on every time through the loop is with another vector. So in this case, I want to say const index is an element in, and in is another keyword, in, some vector of values. And I'm going to repeat this loop for each element of that vector. Now in this case, that vector of values is going to be a counter that goes from 1 to the length of my const init vector. Because basically, I'm going to create a loop here that iterates through each element of const init. Then all the code that's within my loop needs to be contained, within curly brackets. And it's good code style to indent your code. So I'm going to take all the code that ultimately is going to be inside the curly brackets, and I'm going to highlight all of that code. And in a coding text editor like RStudio's text editor, when you highlight this much code and you hit the tab button on the keyboard, it generally is going to indent your code. That's just a setting on most coding text editors. When you hit a tab, it's not going to replace all this text with a tab character. It's going to say, oh, you must be wanting to indent all of the code that you have selected. So again, I just highlighted all this code and I hit tab to indent. If I want to unindent, I can hit shift tab. Tab or shift tab. And then I can add my closed curly bracket at the bottom here, and I want to put it at the same level as my open curly bracket, so it's really clear where my loop starts and stops. So ultimately, this means I'm going to repeat all of the code that's in these curly brackets as many times as there are elements in this vector. And this vector is 1 to the length of const init. In this case, the length of const init is going to be 3 because there are 3 elements to this vector. So recall that the colon is a quick way to create a vector of values, with the first value being to the left of the colon and the last value being to the right of the colon. So that means each time through this loop, const index is going to be the value 1 the first time through the loop. It's going to be at the value 2 the second time through the loop, and it'll be at the value 3 the third time through the loop. Now that we know we're going to go through this loop 3 times, there are things that we want to change each time we go through the loop. Specifically, we have 3 different values for const init. So each time through the loop, we want to use a different value for the initial concentration that we're using for these calculations. Therefore, we want to change the value of const init each time through the loop. Now, just to save myself from confusion, I don't want to call this const init the same thing as this const init, because this is a combination of 3 const inits, and this is going to only have 1 value each time through the loop. So I'm going to rename this const inits just to be clear that it's a combination of multiple const inits and not just a single one. That way, I don't have any confusion when I say that each time through the loop, I want the variable const init to take on the value of const inits, the vector, indexed by this counter or this index that I've created through my loop. So that should hopefully make it clear why I decided to call that index, because I'm going to use it as an index. So that means the first time through the loop, the const index value is going to be 1, and const inits indexed by 1 will give me the first element of const inits for const init, meaning const init will take on the value of 25. The second time through the loop, const index will be 2. The second element of const inits is 50, which means const init will be the value 50 the second time through the loop. Finally, the third time through the loop, the index will be the value 3. If I index const inits with the value 3, my const init will be the value 100 the third time through the loop. So now I should be able to run this script, and my loop runs. And I can look at my results. And my results work as before, but you'll notice that I only have the results for the last time through the loop. That's because I've remembered to change my const init each time through the loop, but at the moment I don't have a data structure for keeping track of all of the results for each time through the loop. So I still have my rate coefficient of 0.1, and in this case I have my init concentration of 100 because that's going to be the value the last time through the loop. And then I have my times and my predicted concentrations and my filtered concentrations from that last time through the loop. So what's happening now is this results variable is just getting overwritten each time through the loop. And I'm losing the information about what happens the first 2 times through the loops. So that must mean I need to rethink how I'm keeping track of my results. So when you write a loop in programming, it's a good practice to create the data structure that you want to use to keep track of the results of the loop before the loop starts. And you know how big it needs to be because you know the number of times you're going to go through the loop. So in this case, I want my results to be a list of values instead of a single value, because I want to have results for each of the 3 times that I'm going through my loop. So a way that you create a blank list of a particular size is using the vector function. The vector function is creating any kind of vector, and there's an argument to the vector function called mode that tells you what kind of vector you want to create. And if you want to create a list mode vector or just a list, the mode should be list. So we're going to specify this character string list in quotes as what we're passing to the mode argument for the vector function. And then we can tell it how long. There's a length argument that we tell it how long this list is going to be. Well, we know that because we need to keep track of the results for every time through the list. So we know I can copy and paste this length of this const init vector right here. So that means we're automatically going to go through this loop as many times as we need to cover all of the elements of what's in const init. And we're also going to create a vector, or I'm sorry, a list where each element of the list is going to contain the results each time through the loop. So now we're all set up with results to be a vector of vectors, where it's going to be a vector with 3 elements for each time through the loop, and each of those elements is going to be a list of the results for that particular time through the loop. And we can handle that with an index of our results, because we now results as a vector, and we can again use this const index as the index to this vector to make it clear that each time we go through the loop, our first element of this list that we created should contain another list that has the results of that first time through the loop. The second time through the loop, const init will be 2. I'm sorry, const index will be 2. And that means the second element of our results list will contain the results for that second time through the loop, and the same thing for the third time through the loop. So let's take a look at what this does. If I run it, now my results are going to look different. Let's go to the very top here. My results is going to have a list element 1, and list element 1 is going to have several elements. The first element is going to be named rate coefficient, and it's going, in this case, it's the first time through the loop, so the value is going to be 0.1. And the first time through the loop, my initial concentration is going to be 25. And I'll have the results of that particular combination of const init and the rate coefficient. Here is the second element of my results vector, or my results list. The second time through, my rate coefficient for the second element is going to be 0.1, and my initial concentration is going to be 50. And here is the results for that combination of parameters. Finally, the third element of this list is going to contain a list with the named element rate coefficient of, again, 0.1, because we're not changing that. But the initial concentration is this time 100, and here are the results of that set of combinations. So we've created a hierarchy here. There's a list of lists, which is a really common thing to do with lists for keeping track of hierarchical information. In this case, the top level of our hierarchy is each time through our loop, which means we're changing the initial concentration each time through the loop, redoing our calculations, and saving those results. The second level of the hierarchy is the list that's keeping track of all of the results for a given time through the loop. It's worth noting that I've used the double square brackets here. And that's really important, because remember, when you use the double square brackets for a list, that means you want to change the contents of a reference, not the reference to something else. So in this case, I'm changing the contents of the index of the element of results each time through the loop in order to put that list in those contents. RStudio also gives us a way to look at this results list that maybe is a little easier to see what's going on in terms of the hierarchical structure. So if I click on the results list that's up here in my environment, in my RStudio view of the environment, what that does is calls the function view with a capital V on that variable. And when I call view on that variable, I can look at that variable in a window that lets me see the hierarchy. So results itself is a vector, or I'm sorry, a list with 3 values in it, 1, 2, and 3, corresponding to each time through the loop. And each time through the loop corresponds to a different value of the const inits. And then I can look at each one of these individually in this window by expanding that level of the list. So results is a list, and each element of results is a list. In this case, the list is named where I have a rate coefficient const in it times const and const filter for each one time through. And you can see how the const in it changes from 25 for the first one through, 50 the second time through, and 100 the third time through.